All right, so here we go. Welcome to Chapter 9. In Chapter 9, we're going to take a look at a little bit of statistics. You'll do a lot more of this most likely when you take your stats course, GBS something or other. I forget the numbers offhand. But we're just going to kind of touch on it. And so we'll begin by taking a look at Section 9.1. And in Section 9.1, we're going to talk about frequency distributions. And then we'll talk a little bit about measures of central tendency. So our objectives here are to talk about how to construct a frequency distribution, including all of those things that are necessary. We'll talk about frequency polygons and frequency histograms and relative frequency histograms. And then we'll change gears and we'll take a look at finding measures of central tendency. And we'll talk about finding those same measures of central tendency for a data set that is grouped or a frequency distribution. All right, so we'll start out with this idea of a frequency distribution. All right, so basically here's the idea. Big giant piles of numbers are ugly to look at and hard to interpret. So we often use a convenient method to display that data called a frequency distribution. And basically all we're looking at here is we're talking about a table that shows us classes or intervals of the data and the count of the number of entries in each class. Okay. That count we call the frequency. We also use the lowercase letter f to talk about that frequency. All right. Each class has a lower class limit, which is the smallest number for that class, and an upper class limit, which is the greatest number for that class. The classes have widths. The class width is the distance between the lower limits of the consecutive classes, and then the difference between the maximum and the minimum data entries are called the range. Right? So this thing over here on the right, this is a frequency distribution. Okay? It has 1, 2, 3, 4, 5, 6 classes. Each of those is a class. All of those classes have lower class limits. All of those classes have upper class limits, and those lower class limits and upper class limits tells you the range of data that would be in that class. So when I take a look at this row right here, I would read that and I would say, well, okay, in the original pile of numbers, in the original data set, there are 6 values between 11 and 15 inclusive. And that inclusive means that 11s and 15s are in that class. Now what those 6 values are, I don't know. I just know they're between 11 and 15 inclusive. They could all be 11s, they could all be 15s, they could all be 13s, I don't know what they are. They can be spread evenly throughout that range. I don't know. Honestly, I don't care, because the idea of a frequency distribution isn't about where the exact values are. It's about trends in the data. Okay? So when I take a look at this frequency distribution, I have classes. Okay? I have lower class limits. That's the number on the left. I have upper class limits. That's the number on the right. The class width for this data set is the distance or the difference between any of these values right here. And what you'll notice is that class width is going to be 5 every single time. You'll also notice that class width exists over here. From 5 to 10 is 5, from 10 to 15 is 5, from 15 to 20 is 5, from 20 to 25 is 5, from 25 to 30 is 5. That class width is 5. Right? That's my class width. And so basically what I'm going to do is I'm going to get a pile of numbers, I'm going to figure out a bunch of classes, and I'm going to find how much data is in each of those classes, and that thing that I make is called a frequency distribution. All right, so how do you make one? Well, the first step in making one is to decide on the number of classes you wish to use. Now that is a number usually somewhere between 6 and 15. I want you to know something. That range of values of the 6 to 15 is not consistent. I've seen it as 5 to 20 before. I've seen it as different values. But basically what we're saying is you use a bunch. How many is a bunch? enough. If you draw it up and it doesn't look good, then do it again and use a different number of classes. If you use too few classes, then the data gets kind of bunched up and you won't really see any patterns in the data. And if you use too many classes, then the frequencies are all going to be really, really low, and that wouldn't tell you any patterns in the data. So basically just look for some nice number kind of in the middle there and make the frequency distribution and see if you like it. Okay? Once you've got the number of classes figured out, you'll find your class width. The way you find the class width is you determine the range of the data, divide the range by the number of classes that you want to use, and always then round up. Okay. This last bit right here is very important, this always round up. If you don't round up, then what can happen is when you get to the end of your frequency distribution, when you get to that last number there, like that 30 in this example up there, that might not be large enough to fit all of your data points. Okay? So just for example, if I found the range of my data, and the range of my data was, I don't know, 38, and I was using 7 classes, then my class width would be 38 divided by 7 and then round up. And so I'd grab my calculator and I'd say, what's 38 divided by 7? And even though that says 5.4, and I would normally say, well, that would be 5, I'm going to call that 6 because the rule is always round up. Okay? All right, once you've got your class width figured out, that's 6 or whatever number it works out to be, then you start by finding all those class limits. You'll find all of these values as well as all of these values. You'll find all your lower class limits and your upper class limits. So let me erase a whole bunch of stuff that's up here to make this a little bit cleaner. But let's take a look at what's going on here when we find these class widths. Hopefully you recognize that where the first one stops, the next one starts one value higher than that. 1 degree of accuracy, if you want to think about it that way. Okay? So for this frequency distribution, the one that I'm talking about here, it looks like our data is accurate to the whole number. So then the next whole number after 5 would be 6. If my data was accurate to 10th place, then this next one wouldn't start at 6. This next one would start at 5.1 because that would be the next degree of accuracy. Right? So we keep that degree of accuracy and we just go for the next value in that degree of accuracy. There is no overlap between the two. You stop at 5, you start at 6. There's no overlap. The reason there can't be overlap is if there was overlap, you wouldn't know which one to put the data point in. Like suppose that this was also a 5. We did 1 to 5, 5 to 10. Where does 5 go? Does 5 go in the first class or does 5 go in the second class? Right? So we set this up so there is no overlap. Right? So I got my class limits. I find all my class limits. And then after I found all my class limits, now I go back to my data set and I actually walk through the data set, data point by data point, and I keep a tally of the appropriate class for each data point. And then once I've done all that tallying, then I count them up and I find the total frequency for each class. So when someone made this frequency distribution, they were tallying up, and when they got done, that one had a tally of 5, and so it has a frequency of 5. Right? Now this will make so much more sense when we actually do an example. So here, let's go. Let's make an example. Here's a data set. This data set contains the out-of-pocket prescription medical expenses in dollars for 30 U.S. adults. So this is going to be the out-of-pocket expenses for medicine for 30 U.S. adults in a recent year. Not very recent, but relatively recent. Our job is to construct a frequency distribution, right? And just to make sure that we're all on the same page, we are going to make a frequency distribution that has 7 classes. Why 7? I don't know. We just have to pick a number, so we're going to do 7. So 7 classes. Right? All right, so what's the first step again? First step is determine the number of classes. Okay, I'm good there. Second step is define the class width. Range of the data, divide it by the number of classes, round up. range of the data. Okay? So the range of the data, I need to find the high minus the low. So what's the highest data point in this data set? Got a 405. Looks like 405 is my highest data point. All right, and what's my smallest data point? 160, 150, 155. It looks like 155 is my smallest data point. So then my range is going to be 405 minus 155. So I'll grab my calculator, 405 minus 155. That gives me 250. I don't want that to happen. I just want you over here like that. All right, so I get what now? Oh, I'm sorry, I said 250. Okay. Then I've got my range. After I've got my range, I divide the range by the number of classes. Okay, so then I'm going to take 250 and divide that by 7, and that's going to give me, let's see, 250 divided by 7 is 35.7 and change, so we're going to call that 36, and that is going to be our class width. Okay, so now that I've got the class width, what's the next step? Let's see. Find the class limits. I'll use my minimum data entry as the lower limit of my first class. So now I'm actually going to start building this thing. Right. So I'm going to have classes, and then I'm going to have the frequency of those classes. My smallest data value was 155, and my class width is 36. So my lower class limit for my second class, right, the number that's going to go here for that second class is going to be the lower class limit of the first class plus a class width. So I got to do 155 plus 36, so that's 191. Okay. I'm going to bring my calculator back up to help me with this, and I'll show you a trick. You ready? Put in that lower class limit, 155. Press enter, then say plus 36. So that's 191. So that's my second class. And then I press enter again, 227. So it's just going to keep adding that 36. So there's my third class, 263. There's my fourth class, 299. There's my fifth class, 335. There's my sixth class. So 1, 2, 3, 4, 5, 6 classes. And then 371 is going to be the lower class limit of my seventh and final class. Now I need to find my upper class limits. Okay? Well, it's actually not that bad, because all I have to do is go one less than the lower class limit. So the lower class limit of the second class is 191, so then the upper class limit of the first class is one less, 1 degree of accuracy, 1 less. 262, 298, 334, 370. Uh-oh, how do I find that last one? Because I don't have the next one to subtract from. So that's going to be 406. And how did I get 406 there? Well, the class width. The class width is 36. So 370, the upper class limit of the sixth class, plus the class width of 36 gives me 406. Now I know what at least one person out there is thinking right now. They're saying, or they're thinking, hey, wait a second. Our data only goes up to 405. That was our maximum. How come our table goes up to 406? Well, this right here. Because we had to round up a little bit, we got that 406. If you want your table to start at exactly 155 and end at exactly 406, what you're going to have to do is you're going to have to use 205 divided by 7 exactly as every single class width. But when that is your class width, then these numbers in here are all going to be ugly. The only two nice numbers you're going to have are 155 and 405, but everything else will be ugly. So by rounding this, and especially by rounding it up, because that's what we always do, you're almost always going to end one, or possibly if you had a big enough rounding there, two above your maximum value. All right, so now what I have to do is I have to go through my data set and I have to start doing that tally business. So I'm just going to make a thing over here for tally, and I'm just going to make this small enough that I can see everything, and I'll go through and start tallying up. All right, so here's the technique that I'm going to use. I'm going to cross them out in that table every single time I use them, and I'm going to use a nice light color so they'll cross out easily so we'll see them. So 200 is in the second class, 239 is in the third class, 155 is in the first class, 252 is in the third right there, 384 would be here, 165 would be here, 296 would be here, 405 would be here, 303 would be here, 400 would be down here, 307 would be there, 241 would be here, 256 would be here again, 315 would be here, 330 would also be in that same class, 317 would also be in that same class. So there's our first bundle of 5. 352 would be here. 266 would be here. 276 would be in that same class. 345 would be here. 238 would be here, another bundle of 5. 306 would be here. 290 would be here. 271 would be here. 345 would be here. 312 is here. 293 is here. 195 is here. 168 is in our first class, and 342 would be here. And now I'll count them up. This has a frequency of 3, a frequency of 2, a frequency of 5, a frequency of 6, a frequency of 7, a frequency of 4, and a frequency of 3. All right? And so I have created my frequency distribution. Right? So my tallies over here on the right, I tallied out of my data set, and then my frequencies here are just the sum of those tallies. Right? Now, if you want to check yourself, what you could do is you could add up your frequencies, and since there were 30 data points, then those numbers should add up to 30. So we're starting at the top, 3 and 2 is 5, plus another 5 is 10, then we're looking at 16, 23, 27, and 3 more is 30. So it looks like I added them up right. I've got 30 of them. I didn't miss anybody. And there's my frequency distribution. Right. Now, realistically, this is most likely how you wouldn't actually create a frequency distribution. You'd probably have some sort of computer software that would do this for you. But that's the idea behind a frequency distribution. I want to display the data. Now, one thing to keep in mind is we have lost some accuracy. And what I mean by that is when I look at this number right here, this 2, okay, that just simply tells me that there are 2 values in the original data set that are somewhere between 191 and 226. It doesn't tell me what those data points are. If I wanted to know those, I'd have to go back up here to this actual data set to get those values. Now the problem is this data set is ugly. It's hard to look at that data set and see any trends or patterns in that data. The idea behind a frequency distribution is that this thing that we just created should give us some idea. And when I look at it, I'm hoping you're seeing the same thing I'm seeing. that it looks like most of the people are here. I mean, there are some people on the low end, there are some people on the high end, but most people are in this range, those three classes right there. So I would say it looks like most people spend 225, 227 to 334, 225 to 350, somewhere in that range of values is what most people, it looks like, are spending on their, this was out-of-pocket expenses, right, for medicine. Frequency distribution. A different way, another way that you could label your table is, rather than using these classes over here, is sometimes we use the midpoints. So if we want to determine the midpoint is always the lower class limit plus the upper class limit divided by 2. So if I wanted to relabel this to make it cleaner, because sometimes when people look at this, they think, oh, that's kind of ugly. What I could do is I could just find every midpoint. So I could say, okay, the first midpoint would be 155 plus 190 divided by 2. And then I would grab my calculator, 155 plus 190, divide that answer by 2. And I would say that the midpoint of the first one is 172.5. And then if I wanted to find the midpoint of the second one, well, I could go 191 plus 226, but I could also just add 36. Because if the lower class limits are all 36 apart, and if the upper class limits are all 36 apart, then the midpoints are also all 36 apart. Now, there's lots of things that we can do with a frequency distribution. We could, if we didn't like these numbers right here, we could rewrite those numbers as percents of the whole. And so we could rewrite those as a relative frequency, where we would take that class frequency and divide it by the sample size. Right? Or maybe we could rewrite that instead of just being a frequency or a relative frequency, maybe we could write that as a cumulative frequency. So there's lots of things that you can do with a frequency distribution. And so here's our frequency distribution. This is what we had right there. Here's all those midpoints in case you don't like the classes written that way. Our relative frequencies here give us an idea, a proportionality of each of those. And so where did those numbers come from? Well, 3, 30, 3 divided by 30 is 0.1, our relative frequency. 2 divided by 30 is going to give me a relative frequency of 0.07. What you will sometimes also see is you will sometimes see those represented then as percents. So 10%, 7%, 17%, 20%, and so on. Okay. Now, one thing to keep in mind is this should add up to 1 or 100% if using percents, but given that some of these divisions aren't going to be nice and that some of these numbers are most certainly rounded, if you were off by a little bit, it'd be fine. What I mean by a little bit is, let's say that when you added this up, it added up to 0.99, or if it added up to 1.01, that'd probably be fine. Maybe even 0.98 or 1.02, but if it added up to like 0.95, then we'd have issues, because you're 5% off there. You shouldn't be 5% off on a frequency distribution. Maybe 1%, maybe 2%. What's this last column? Well, the last column is the cumulative frequency. And so it goes 3, 5, 10, and where are those numbers coming from? Well, think of this cumulative frequency as a running total. Okay? And so the 3 there is the 3. The 5 is the 3 plus the 2. The 10 is the 3 plus the 2 plus the 5. And so basically what we're saying here is by having a 10 there, we're saying that there were 10 people who paid $262 or less. There were 23 people who paid $334 or less. So it's this idea of finding the running total of what's going on. Now, none of these things, whether it's frequencies or relative frequencies or cumulative frequencies, none of these are the correct way to make a frequency distribution. They're all just different ways to make a frequency distribution. Our goal here is that data sets can be ugly, and we need a way to give the information out in a non-ugly way. This pile of numbers is ugly. I don't want to look at it. I can't see patterns in it. I can't detect what's going on. If I stare at it for a long time, maybe I might be able to kind of see a little bit. But when I look at a frequency distribution, I can see where lots of people are spending here, only a few people on the low end, a few people on the high end, most people are there in the middle. I can read into that information a little better. And if frequencies don't make sense to me, like if I don't know if 5 is a big number or a small number, maybe rate it as a relative frequency. And now I can look at it and go, oh, look at this. 23, that's almost a quarter of them. That's almost 25%. That's almost a quarter of the people that are in this range. There's a lot of people in that range. Now, obviously, I can also see that 7 is the biggest number over here, but I don't know what 7 is. And 7 out of 30, maybe I'm having a hard time with that. So maybe percents or relative frequencies are what I really want to know. Right? So when you think about a frequency distribution is just a way to display the data. Right? We're at 26 minutes, so I'm going to end this one here. We're going to come back and take a look at ways that we can take this frequency distribution and turn it into a picture. That is to make a graph out of it. So I'll see you back here for part 2.